Now let us begin by understanding what is this distributed computing continuum. Let's have a high-level view of this infrastructure that we are talking about, which is here to support the AR and VR industry. On the left-hand side, you can see the world of the sensors, so the IoT world, which is highly volatile, it is low energy, it is very mobile. And as we move to the right in this picture, you can see that we have edge computers, which are at the boundaries of these sensors, like AR and VR technologies. As we move to the right, we come to the edge infrastructure. So the edge infrastructure is then really about processing where the data is being created. And on the far right, we can see the cloud computing infrastructure with its unlimited resources and storage potential, which is well known in the IT industry now for more than a decade. So the compute continuum that is essential for us with an infrastructure perspective looks at this whole ecosystem, we call it computing continuum, and tries to create a resilient infrastructure, a robust infrastructure for this whole area of computing. So this means that we look at the world of systems not just as a separated piece of technology, but we understand that the infrastructure is foundational to support all the computation and all the storage necessities which AR and VR has to run on. Now, to give you a very simple example of the field of AR or VR, consider this example of the person on the bike riding in the urban environment and having an AR sensor, a glass, for example. And with these glasses, the bicycle rider is basically understanding what is going on in the surrounding, in the overall context. So he is seeing what is happening on the street. Are there cars coming across? So there are sensors involved providing information to the rider. And this, of course, requires infrastructure on the edges of the network, represented here with the runtime edge node. And the edge node also comes with artificial intelligence board assisting the processing of the data which comes in. So here you can have a very simple example of how the infrastructure has to be coordinated or orchestrated in order to make these solutions being executed on that infrastructure. There are many interesting examples for AR and VR, which we call intelligence augmentation. So this edge computing power means that we can augment intelligence by providing AR and VR capabilities, for example, for field work, for mixed reality training, for reality situations or virtual discovery of situations in different settings of the urban environment. All of these examples that I'm giving here, they always require a robust and a resilient underlying infrastructure. So when we observe what is actually required, we can say that we require location-based access to the data from the environment at different levels of fidelity. We need compute resources and storage resources in the close proximity of the data producers and consumers. And we require edge intelligence, and that is a post-cloud computing paradigm at the intersection of human augmentation, Internet of Things, so the world of sensors, and artificial intelligence. And edge computing is a key enabler for this. Now, this edge computing, this distributed compute continuum fabric, as you can see here, provides us the foundational building blocks to make all of these happen. So from the world of the sensors, the IoT world, the world of AR and VR, we need to bring those data up to the higher levels of abstraction and make decisions on where do we do the computation, where do we do the storage, where do we do the processing, so that not everything is done on the cloud infrastructure. Many things need to be done on the edges of the network. And this is foundational for AR and VR applications as well, because of the latency requirements of these applications. Secondly, the artificial intelligence requirements for these things are also pushing the data to the edges of the networks. This compute continuum infrastructure is extremely diverse, which makes it a very interesting part of research in the AR/VR industry as well. So we have everything from data center technologies, as you can see here on the left-hand side, to the right-hand side, to microclouds, Raspberry Pi, little computers with very little energy consumption. So the question is, how can we bring AI to these things? And we see that we have even specialized compute platforms nowadays where these AI particular technologies are being put on top of these little infrastructures as we have seen before. So we have specialized compute platforms on top of those. But we don't want to write software for each of these different platforms in particular, right? So we would like to write applications and just deploy them and let the infrastructure have this intelligence. This is the ultimate goal that we would like to achieve in the next couple of years. So write the software once and then let the infrastructure decide on which parts of this infrastructure should the software be deployed and executed. So the question for us is, which characteristics of this edge computing infrastructure should we use as first-class citizens, so to speak, in this model? The first part is, I think, elasticity. Elasticity is a foundational principle to bring resilience into the world of systems. Elasticity is a principle we know from physics, which means that if you put force on a material, it deforms. If you take away that force, it goes back to its initial form. And this is what we would like to emulate in the world of systems. So elasticity can be much more than simply scalability. Where scalability builds the infrastructure for the worst case, elasticity can bring more semantics to the table. So elasticity means, on the one hand side, resource elasticity. You can have more or less resources. This is well known. But there are two other very important dimensions. One is quality elasticity, so the quality of the data input and output. And the third dimension is the cost elasticity. So for the first time now, we can build systems which are operating on an infrastructure which is aware of the quality and the cost and the resources that are required to be executed. And this is a foundational step forward. Now, we would like to make this happen on the infrastructure, as I was speaking about before. So we developed a model in our research to have service level objectives being specified up front. So for the type of application that we are developing, we can specify what are these three-dimensional spaces, how do they look like regarding resource, quality, and cost, and map that into this three-dimensional space we call the Cartesian blanket. And all of these different aspects or configurations determine a space in this hexahedron as it is represented here. So we can say then that we have a configuration of the overall infrastructure represented by a blanket, as you can see in this picture here. So these blankets specify the exact possible configurations of the infrastructure as it is allowed to be depending on the specification that I have given. So this allows us to follow the life cycle of the application, these three dimensions, as you can see here on the picture, and look at the elasticity space over time. So does my application behave according to the specification, and what is the pathway regarding my application? So regarding the costs, regarding the resources utilized, these resources can be from the edge part, can be from the cloud part, and from the quality requirements which are inside and outside of the data flow. So this allows us to be very cost efficient, resource efficient, energy efficient. The second aspect, which I think is a foundational principle, relates to the question of diffusion. So in chemistry, there is a very foundational process called osmosis. We model this from nature, essentially. So we call it osmotic computing. And here the idea is that, like in chemistry, where osmosis represents a diffusion of higher, from molecules from a higher to a lower concentration solution, we say that we would like to have a foundational principle in our world of the infrastructure where software services actually can be deployed on different parts of the infrastructure, depending on the elastic diffusion principle. So this means that the services themselves, they move between the edge of the network from edge computers, maybe specialized AI boards, to the cloud computing and vice versa, depending on the requirement of what is needed. Automatically, of course. So this is where edge intelligence comes into play. We don't want to be explicitly programming these things. We want the infrastructure to be intelligent enough to know where these services need to go. So we have developed the software for that, so that we call it the osmotic pressure. Once that pressure is given, the services know what to do in this overall infrastructure. This means then that data locality and computation becomes intelligent. So whereas nowadays we have to explicitly say this computation goes here, that data is stored there, we can rely on the overall infrastructure to be intelligent enough to do that. So this means that we have an intelligence about, or a awareness about proximity of the data producers and consumers in these internet-based networks. We have an understanding about the elastic diffusion principle, about required load balancing infrastructure reconfigurations in these networks. So this means that locality, contextual awareness, privacy boundaries, etc., are built into the infrastructure, and it is not required for us anymore to make that explicit in our buildings. So to conclude this presentation, there are three takeaway messages I would like to emphasize. The first one is that we look at the infrastructure as a distributed computing continuum. So not as isolated pieces of technologies, but rather on a compute continuum. This means that we have everything from little IoT sensors, AR, VR, infrastructure pieces, to edge and cloud computing infrastructures. And we need to utilize all of these different building blocks together and not in isolation. Secondly, I made the argument for edge intelligence. The complexity of the systems that we have nowadays require that we put intelligence into the infrastructure and not to the software application itself. And the third is that we require fundamentally novel mechanisms for this infrastructure. And I made a very short presentation about this principle of what we call elastic diffusion. So with that, I thank you very much for your attention.